Hi guys, welcome to Learning Electronics Repair. This is the Synq with a Q 2K2 digital amplifier. We see here, not really digital these, they are just Class D amplifiers. But anyway, that's what we have. In the last video we looked at the 3K6, the higher rated model that has a problem in the power supply, some short circuit components, and a damaged module which we can get. So that one's basically waiting parts. The reason this is loose, by the way, I've just taken this off, and this is the voltage regulator board for the plus and minus 15 volt supply. I'll show you why I've taken this off in a moment, but I will show you what's on there. So KA7915, 7815, this is the plus and minus 15, and then there's a TIP something or other, TIP122. This is a Darlington transistor. This I'm sure will be used as another voltage regulator for another supply, okay? Now the reason I've taken that off is because I want to measure the voltages on this first to see why it is just stuck. Not in protect, but the limit lights come on and stay on. I'll plug this in actually and just show you what it's doing. Okay, so you can see the LEDs here. I won't use the current limiter because I know this isn't going to blow up. We tried it previously with it here on the previous video. Hope you watched that, by the way. I think it was quite interesting. So let's just power this up. Okay. Nothing happens. We're going to press the on switch and power it on. It's on, and you can see all the lights are on, fans are running. And this actually has a fault on one channel now the limiter's out. So you can see there, one channel is actually okay. So one channel is actually not lit up at all. Another one has signal, but there is no signal. Okay, click, limit, and protect all lit up. So that's actually behaving differently from when I had the current limiter in. That's quite a common thing with amplifiers, it seems. And this may actually effectively mean I didn't need to take this thing off here. I'll show you why. So this is the schematic for the amplifier. For the power supply, I have the layout for both, so I have plenty of information here. Okay, and I have the service suggestions. So these problems are related to the power supply. We know we don't have a problem on the power supply unless it does power up, but I do want to check the voltages. Having said that, though, one amplifier appears to be okay, so I'm pretty sure that means the voltages are okay. This is talking about that little board, the one where I've taken off the cover. Okay, saying both amplifier channels will not work if 78L15. So it's saying 75L, I think that should actually be a 78. But these are the two voltage regulators. Mine are KA, different make, same thing. But he's saying if these voltage regulators are not working, then both amp channels will not work, and it will cause a couple of diodes, D13, D14, to burn up. Okay, but we have one working, so that seems unlikely, but we're going to check it anyway. And then we have a list of common failures, okay, on the amplifier, and suggestions of how to replace it, what to do. Okay, so let's now check all the voltages. And then if the voltages are okay, which I'm pretty sure they will be because this amp seems to be working, then let's get these two amplifier modules out. We have those list of service suggestions, which is very useful. Let's see if we can figure out what's wrong with this. So to measure the voltages, I need a ground point. It says ground by this one. You can actually see that comes up onto the amplifier here, and on this one down under there you can't quite see it. That is your ground. So we'll stick our black meter lead down here. Okay, just make sure we have a good connection. We do. And then we can probe the voltages. So we have plus and minus 145, I think they are. and we should have the plus and minus 15 on here and whatever's on that one. Okay, so power up. This is the minus 140 something, say minus 112, okay, plus the same, and then on these, so that's 25 coming in, that's minus 15 going out, that's got nothing, that's ground, yeah, it's 15, that's just a different pin out on this one, the in is here on this one, okay, and then let's have a look on this one here, so that's a 24 volt supply, 14 or 15 coming out of it. Okay, so it looks like the main power supply rails were a bit lower than I would have expected, but they're even. The plus and minus 15 are there. I'm sure if I found out what that component is, I could check that voltage rail. But because, again, we have a problem on one amplifier module and not on the other, I suspect anything that is like common to both, i.e. power rails, are probably okay. So I'm going to get these amplifier modules out and let's see if we can find the problem, and we can use the service manual information as well if there's nothing obvious straight away. I'll just check to make sure the capacitors have discharged. This thing could hold a lot of nasty voltage in it. You see it starts 35, 36 volts on there. 35, 36. So I'll wait until that voltage has gone away. Take a few minutes, I think, and then let's get these amplifier modules off. I did check previously, by the way. In fact, I can do this while there's voltage on because it's just fuses. All the fuses on this are good, okay. You wouldn't normally do this if you think you have a bad one, but you can see the fuse is good. The reason I say you wouldn't normally, if there's voltage on, you'll put voltage across the meter. See, that fuse is okay. That fuse is okay. That fuse is okay. So all the fuses are okay. So whatever's wrong on one of these is not blowing the fuse, that's for sure. That suggests there's either nothing short or there is something short and something else has gone open circuit rather than the fuse. Here's the amplifier module. I have both of them. This is the good one. Okay. And this is basically like three things stacked up. So we have this little module that fits on the top of it. This is similar to the module on the power supply that we were looking at on the other amplifier. So this basically just sits here. This does the pulse width modulation, controls all the LEDs, the signals. So this is like the brains of the unit. And then we can see here, we actually have a couple of, I think these are 14 volts. These 14 volt regulators. In fact, no, it says L plus 14 and H plus 14. So this is 14 volts above. When it says L and H, I think it's related to the gates on these. High gate, low gate. This circuit is driving the MOSFET. So we have two MOSFETs in the output, okay, driven from here. So this is with reference to effectively on this low side, it has a ground reference here, Luke. And this is 14 volts above it, I think. And then this is with reference to this point. 14 volts above, at least that's what I think it is. Low plus 14 volts, high plus 14 volts, okay? That's because the source of this MOSFET is not referenced to the same place as this one is. This one goes down to the minus 147, that's the fuse, Luke. There is a resistor here which could have run open circuit, or 60. If there is a short in here, if the fuse isn't, and they see another one, 15 milliohms or 59, again, that's the other fuse. So to drive the gate of this one, you've got to drive it in relation to the voltage on the source. Gate source voltage, that's what switch it on, switch it off. This is your pulse width modulation. And then to drive this one, it has to be with reference to the source, which is a completely different voltage. Do you see that? So that's what this thing is actually doing from how I see it. This part of the circuit, well, I was going to say it's replicated there, but it's slightly different. This is your protect, by the looks of it. Okay. Out to your speaker. Yeah, there's a limit on that one. P limit, P protect. That is an output from the collector, okay? An output, and that seems to go into this brains thing, which I think then effectively is what is controlling the LEDs and doing other stuff. Okay, so let's go back to the PCB. I mean, that's a rough idea. I'm not going to go right into depth with this unless I have to. But I can basically see what it's doing. So on here, we have the module, the brains, okay? I've put a white X on the bad one. That goes onto this PCB, which plugs into the main PCB. If we just lift it. When I say main, I mean the one with all the power components on. Yeah, out it comes. There. So that's the PCB. This has just a chip. I'm not sure what it is. I'm sure I can find from the schematic. Possibly these here. See these MOSFETs here and here are what are driving those by the looks of it. So this is probably like the driver for that. Yeah, there's another components under here as well. I'm sure it'll be on the schematic. And then this is your main output. So let's just check this out. We'll start with the base one. Fuses are okay. I don't think there'll be any short circuits on this because it's not blowing fuses, but it could, for example, have blown these low value resistors and then somebody's changed the fuses afterwards. These will be somewhere in the circuit, probably between the source and ground, or between actually the two sources which join together, because they don't go to ground, they go to the speaker. So I'm in diode mode. I have two diodes here, it looks like, and then two MOSFETs. The numbers have all been scraped off, but we have the schematics so we know what they are. This one reads open that way, and that's a diode junction, like a fast rectifier type diode. Other way again, that reads the same. The MOSFETs, gate, drain, source probably will just read open, and between the drain and source will read open. But if we go in the reverse polarity across the source to drain, we'll probably see a diode. Yeah, there and there. So this is the parasitic diode which is inside the MOSFET. It's in the reverse direction with the positive to the source and the black to the drain. So we also know which was drain and which is source. If these were P channel, it would be the opposite way around, okay? The direction of that diode. So when I say we know the direction of the drain and source, only if we know if they're N-type or P-type, yeah? Because that would be reversed. The other thing then I think we should check is just the low value resistors. So we see one here. I go on to resistance range now. There's one here. Reads basically short. Again, I'll just zero my meter, so we'll go into the low ohms range. Calibrate. Okay. Yeah, still reads basically zero, the very low value. Reads the same. And then we have the two larger ones here and here. Okay, so one of them is here. And the other one is here. So they're all okay. There's no open circuit components there. So I think what we need to do now effectively is to figure out which module or which combination of modules have faults. Now this one is working. So we have two options here. Okay, we have two choices. One is to put the good bits onto here until it works, and if it doesn't work then we say it's that board. The other option is to put the bad bits on here until it doesn't work. Which is the right one? Well, I'll probably say the right one is the one that you didn't decide to do, because you can pretty much guarantee whichever one you decided to do was the wrong one. That's just sod's law, yeah. But I'm going to go with testing these individually on here. Try one and then try the other. And if it still works with either one or the other, we know the problem was on that base panel. And if it doesn't work with one or both of these, I'll try them both on here individually, then we know that one or both are faulty, okay? Because the way this is behaving, we have pretty much all of the lights coming on the bad channel, not just protect, but we have 4 lights, even signal is lighting up. So my first suspicion is that the problem is in this thing. This is like the brains of the unit. We can see that on the schematic, okay? If the problem was something external to these, then you would expect the same thing to happen on both amplifier channels. So I think we can also eliminate that. I've put this channel back in. I've just left the other one out, as I mentioned. We'll power this up again. This is the one that was working, so I'm assuming it's going to work. Assumption is usually wrong, let's see. So we'll just power this up. Switch it on. Yeah, and all the lights go out. Okay, so that's good. I'll just wait to make sure the big capacitors have time to discharge. Might take a little while, and then we'll start swapping stuff around. You don't really want to start swapping this stuff when there could be quite a lot of power still in here. Maybe we can actually have a look at that. So I'll just connect to ground. Let's have a quick look. Yeah, 51 volts on there. And the other one's a bit hard to get at, but we can pretty much assume that the other one also has a lot of voltage. I'll actually go to the other connector on the other channel, 38. So I'm just going to leave it a few minutes. I could discharge those capacitors using resistors, but time for a drink and then we'll have a look. Just Cola Zero, by the way. Okay, I think we're good to go now. Yeah, no voltage left in that anymore. Okay, so we'll try this. It's a little bit awkward actually with this plug in here, so we'll just take that out of the way, make life easy. Try the other one. Right, what does it do? All the lights come on and stay on the same. So that module is faulty. So what I will do now is I will take the good module, the one we know works, and put that onto the other amplifier channel and see if it also works on there. Then we will have effectively tested everything and we know it's just this. And it goes out. So everything is okay on that channel. It's just this module. I've searched for the digital module 101. Okay, digital amplifier 101. And that brings me to this page. Now I notice this says 101B. Okay, reference for 3K635. Okay. And I looked at the other amplifier and that has 101A in it. That is the 3K6. We come back into here and we just search for 101A. There is in fact a 101A. Okay, this has slightly different reference, but they both say they're for the 3K6 and the 2K2. And the problem is I don't know which I have, so these are the ones out of this 2K2 amplifier. We know that one is faulty. Okay. I've taken one of the modules off the other amplifier. These look more like the one on that web page. I think these are kind of a third party or something. These are 101A. But I honestly don't know at the moment if I can just stick the 101A in here. Should this be a 101B? These don't say it all. What is the difference? That's the question. So I don't really want to stick this onto here I'm not 100% sure something bad would happen, but I know everything on here is okay, and it's just a risk I don't want to take without a bit more information. So I need to order the parts for the other one anyway, so I'll message this company. I'm going to ask them what the difference is between 101A and 101B and how to determine what type I have if it just says 101 on it, okay, and see what they say. It would have been nice to put this one in plus this one and say we have one working amplifier, he can pay me for that, but it's just one risk too far for me. What do you guys think? Yeah, would you just stick the thing in there and see what happens? Because you might see something bad. Yeah, who knows? Okay, so that's where we are with this one. We've had pretty good results, I think. We know basically enough to repair them both. We certainly know what this one is, just which module. And I think the other one on the previous video, once we replace these short circuit MOSFETs and we change that module, that'd be good as well. Okay, so let me know, comments below. I look forward to hearing from you, and I also look forward to seeing you all again soon on Learn Electronics Repair. Ciao for now, guys.